In Lesson 11, we are going over the addition of fractions and inscribed angles. Okay, our first example is adding k over 2a plus bc over ax squared minus m over ax cubed. Our first step is to find out what is our common denominator. So first I start by looking at the coefficients, and these have the understood 1 and this has a 2. So 2 is going to be part of our common denominator. And then I look at the a's, and they each have an exponent of 1, so it'll be 2a. And then next I'm looking at the x's, and you want to use the variable that has the larger exponent. So we're going to use x cubed. Okay, so we're going to have the 2a x cubed as our common denominator for each term. Then we'll make sure we get our signs right. That one's minus, this one is plus. Alright, now the 2a already has, or the k already has the 2a under it, and I would have had to multiply x cubed to get 2ax cubed. So I need to multiply the k by x cubed. So k x cubed. Okay, for our second term, this ax squared does not have the 2 and the x is only squared. So I need to multiply the top by the 2, and the b and c will just stay the same, but it needs another x, so I have to multiply by the x also, so it's 2bcx. Okay, in our last term, it also needs the 2, and it should be subtraction. Doesn't like my subtraction. Right. It needs the 2 because it does not have that. It only has the 1. So I have to multiply the m by 2, so 2m. But it already has the ax cubed. Okay, so we leave the rest alone. Then we need to make this into one big fraction. So they all have ax cubed now. I'm just going to put those all on top. So I'll have k x cubed plus 2bcx minus 2m. Okay, and that is our answer. We've added our three terms together. Alright, the second example, we're adding m over k minus b plus cx over ak squared. Alright, again, we start by finding the common denominator. So we need an a, because this one has an a, and then we're going to use the x, or the x, that was the last time, the k squared. So there's three terms, they each need to have a k squared in their denominator. Okay, and then it's a minus. Does not like that minus. Okay, and a plus. Okay, the m already had the k on bottom, but in order to make that ak squared, I'm going to have to multiply by an a and a k. So it's a, k, m when I multiply those together. Okay, the b actually has just an understood 1. So I need to multiply that by ak squared. So it's going to be a, b, k squared on top. Then for the third term, it already has the ak squared, so it's just going to stay a cx because it already had the common denominator. It didn't need to change. Okay, now we need to write this as one big fraction, so we have our ak squared on the bottom. Okay, then we have our akm minus abk squared plus cx. Okay, and then that is our answer. We've added them all together. In the third example in lesson 11, we're looking at an inscribed angle, and remember that it doubles here. So with the 40, that means this opening is 80 degrees on the circle. Okay, and we're asked just to find x. You need to remember that there's 360 degrees in a circle, and what we're going to do is add our 5x plus our 7x plus 40 and also the 80. So we're adding all of these parts or sections together to equal 360. Okay, so we'll get our like terms together. This is going to be 12x. And then, there we go, 120. Alright, then we want to get the x term by itself, so I'm going to subtract 120. Okay, so 0, 4, 2, 12x, and then just divide both sides by 12. So x equals 20. And we found x.